let's get up here. Let's upload. Here we go. And probably my pen won't work since I haven't actually even tried to make my pen work today. Man, what a slow day. All right, 14. Spacecraft orbits the Earth, circular radius R shown above. When spacecraft's position P, a short burst to the ship's engine results in a small increase in its speed. New orbit is best shown by a solid curve in which of the following diagrams.
I thought it would be E, but that's what if it was E, I was sure why it would be E.
It's the answer is never. It's never going to be E.
Why?
It just doesn't happen.
Why? I don't know that. What? That'd be so.
Whenever you have an orbit, it's always going to be close to, going fast, far out, going slow.
Yeah. Couldn't you have?
You got two close in and two far outs? I don't think that's even going to be a stable orbit. Right? Because you're trading, what are you trading? You're trading potential, you're trading kinetic energy for potential all the way out.
Yeah.
So you couldn't do potential to, kinetic to potential, back to kinetic, back to potential. That'd be kind of strange.
Why?
Okay, the other way to do it, another way to look at it, maybe this is a better way to look at it. What you could say is that if you kick an engine this way, right? You're going to have additional kinetic energy, right? You're going to keep going out until you bleed it all the way off, right? And so you're going to go to the highest potential someplace down the road, right? Yeah. To keep your orbit stable, you still have to be going in that direction, though, right? So you've given yourself additional energy. You've got to bleed off that additional velocity by going farther out. The truth of the matter is that the E always appears on answer keys. You'd have to work so hard to make that orbit happen. If you just kick yourself additional energy, what happens is you go into an ellipse. That's it. Red 14. There should be one in the middle of this packet. If there's not, there's one in the middle of the next packet. They're not. Right before the free response questions. There's an extra one in there. This is back when this test was first issued out. They didn't actually give people formula sheets for the multiple choice. All right, chapter 8. Sorry, chapter 8. Problem 8. Problem 8. Okay, I've got a string problem. At least it looks like one, right? Nope, it's a plane. I'll do the next problem already. Let's do the plane problem. Plane, I've got a plane. It rolls without slipping. What is the speed of V center of mass at the bottom of the inclined plane? All right. Sphere of mass, ooh. Rotational inertia I. Okay, so they gave you the inertia I, so you have to think about that. Okay, so rotational inertia I, rest, is going to be inclined plane. Okay, so you're going to go rolls without slipping, so you got mgh becoming what?
Kinetic.
1/2 mv squared plus 1/2 inertia angular velocity squared. Yeah. If that's the case, then I should be able to solve this in some fashion or another. For rolls without slipping, we got we do it in terms of v. Velocity of center of mass. So I'm going to do omega r equals v. So that works. So omega equals v over r. Agreed?
Yeah.
All right. Let's blow through this problem as best we can. We got mgh equals 1/2 mv squared plus 1/2 I. We're going to use I. This becomes v over r, the whole thing squared. Agreed? All right, I got to collect my V's so I can solve this problem. So to do that, I'm going to note, they didn't give you inertia formula. I keep wanting to change my inertia into something else, but they didn't give it to us, right? So we're going to have to keep going. So let's blow through this. We got mgh equals 1/2 mv squared plus 1/2 I over r squared v squared. Agreed?
Oh, yeah.
And if that's the case, I need to solve for v. How am I going to solve for v?
Divide each side by.
It's a trick we just used in implicit differentiation, a truckload.
Yeah, like divide.
We don't call it dividing, we call it factoring out.
Okay.
Okay.
Factoring out the 1/2 m plus 1/2. Yeah, and then we divide the factor out.
Yeah, I might pull the 1/2 out. Is there any chance there's a 2 sitting and floating in any of these?
Yeah.
There's a 2 floating in any of these? But it's inside half the time. Interesting. Yeah, I'm going to float the 2 out anyway, 1/2 out anyways. So I got mgh over m plus I over r squared, which I'm going to have to deal with, right? Is equal to 1/2 v squared. Yeah. Okay, to deal with that, I got to get the r off the bottom, which means I need a common denominator.
Oh boy.
All right. mgh over mr squared plus I. Now I can flip the r squared on top, can't I?
Yeah.
Okay, r squared on top is equal to 1/2 v squared. So 2 mgh r squared over mr squared plus I equals v if I put a square root bar on it. Is there any chance one of the answers? mgh, I got an I plus mr squared on that one, 2mgh, that's it, E.
Now you have the r squared on top of it. Yeah.
Well, because
Well, that's.
when I do the common denominator here,
Oh.
I get an mr squared because I had to make that r squared.
Oh.
That puts an r squared on the bottom, and we're good enough at math now, we realize all we're going to do is flip and multiply, right? So it's going to go on top.
Yeah.
And so I just flipped it up on top. I did that in one step. If you need to do it two, you can do it too.
And then. Okay, never mind. Okay.
Is that okay?
No, that works. Whoopie.
Pausing for posterity.
Sure.
Well, they do have an answer key in the back.
Well,
But you want to know
sure
what?
as
Okay,
to
that's fair.
why.
That's fair too. 10. I've got lots of figures, lots of bad things happening here. All right, that's fun. Which figure best represents a free body diagram for the box accelerating up the ramp? Accelerating up the ramp. F is friction? That's friction. So friction will be stopping us. Gravity pulls down. Force normal is going to push up.
We need to force it like.
I like none of these. Can I choose none of these? Force of pushing? Oh, there's a force pushing it up?
Yeah, that's what.
Probably should read that question better. The box is following frictional forces. Okay, so the only one that could possibly make sense is number E, right?
That one's good about that.
Okay, because you got force normal, you've got force of friction pushing that way, you've got force of pushing, which I don't know why you need a force pushing because you can be sliding upwards without it. Not long, but you could be.
Well, yeah, that's.
Okay, so that would say that's E, right?
Okay, yeah.
And then we're going to look at 11. 11 says, which figure represents the free body diagram for the box, which is at rest on the ramp. Once at rest of the ramp, what's going on?
Well, it doesn't have friction. Oh, that one doesn't have.
Force normal. It's got force friction holding it up, right?
Right, that's true. But
It's going to have force of weight pulling down. Which one's that?
well, but
C. Which question?
But couldn't it also have like? Oh, so figure B just doesn't weird force normal.
Yeah, force normal in that direction.
That's really weird.
That's not good. We can get rid of B right off the bat. It makes no sense. D is tricky and evil. Why is D tricky and evil? Because you don't show components on a free body diagram.
Okay.
So I can get rid of D right away by saying you don't show components on a free body diagram. So once you get rid of those two, we're down to 3 choices. A, C, and E are the only 3 that could possibly be right answers. Oh, A's doesn't make sense either because it's not pointed straight down, right? MD's not pointed straight down. So I'm down to C and E are the only 2 diagrams that could possibly on planet Earth make any sense at all.
Okay. That helps.
Let's talk about 12. Which figure best represents the free body diagram box is it sliding down a ramp at constant speed? At constant speed? That's still going to be C, right? Just the component of gravity is equal to the force of friction. Right? If we now we draw in components, right? It's not a free body diagram. Free body diagrams do not have components on them ever. And it's a trick my kids probably fall for more than anybody else on the planet because I pretend like force parallel is a real force. It's not, right? It's part of gravity. So we would draw these two components, right? This component is going constant velocity equal to that force of friction. Is all that's going on, right? But you don't get to draw this component in, even though you desperately want to make sense of the picture. Yeah?
So do they normally just throw in free body diagrams that don't make any sense?
Well, again, they're going to have to not make sense, right? For them to say that for sure has to be wrong, right?
Yeah, I guess.
That's the game they're playing there. Is it wrong? That's interesting. They gave you 3 free body diagram problems. I guess they're getting away with inclined plane counts too.
You do 20.
Let's do 20.
Probably just
19, then 20. Oh, now you're messing with me. All right, look, hold on. I'm gonna pause.